For this problem, we want to figure out the present value of a series of cash flows, multiple cash flows, and the trick with this, or the key to this, is the fact that there's two cash flows and they actually have different signs. So you're going to buy a new car, or you bought a new car, and in 2 years you're going to get a rebate, meaning you're going to get money, you're going to get $2,000. And then in 4 years, you have to pay $40,000. So the cash flow is going to be negative $40,000. The problem even says the correct answer is less than 0, but it's important to make sure to pay attention to negative for a cash outflow, positive for a cash inflow. So we know the cash flows in 2 years and in 4 years. We're given an interest rate, a discount rate of 12.3%. So we assume it's 12.3% per year. No compounding period is given. So since the cash flow is going to be expressed as a year, the interest rate as a year, and there's no compounding, it's appropriate when we make our timeline to have our notches represent a year. So what happens at time 0 and time 1 and time 3, there are no cash flows. In time 2, $2,000, because you will get that rebate. In 4 years, the cash flow is minus $40,000, negative $40,000. Why? Because you're going to be paying the $40,000. The discount rate is 12.3%. And so all we need to do is discount the 2,000 back 2 periods and discount the 40,000 back 1, 2, 3, 4 periods. We figure out the present value of getting 2,000 2 years from today. We figure out the present value of paying 40,000 4 years today, put them together, and that'll be the present value of all of the cash flows together. So what is the present value of $2,000 in 2 years? Remember, the present value is simply the cash flow over 1 plus the discount rate taken to the power of how many years it is in the future when that cash flow happens. So when you have multiple cash flows, the present value today is simply first cash flow. You don't need a discount because it happens today, over the present value of the first cash flow, plus the present value of the second cash flow, which is what that cash flow is, divided by 1 plus the discount rate squared, plus the present value of the third cash flow, plus the present value of the fourth cash flow. Well, this is pretty straightforward. In this case, 0 plus 0 over 1.123 plus 2,000 over 1.123 squared. So again, we're going to get 2,000 in 2 years, so when you discount it back, essentially the discount rate per period is 12.3%, but since we're getting it in 2 periods, we take that into account there. There's no cash flows expected in 3 years. And then in 4 years, we're going to have to pay $40,000. That's the big check on the car. But the good news from our perspective is that it's in 4 years, so it doesn't actually cost us $40,000 because we don't have to pay it for 4 more years. So what is this equal to? It's equal to 0 plus 0. 2,000 over 1.123 squared is equal to $1,585.88. erase this. Plus 0, because there's no cash flow in year 3, plus minus 40,000 over 1.123 to the fourth is equal to negative $25,150.17. So even though you got to pay 40,000, the fact that it's 4 years later means it's really equivalent to paying roughly $25,000 today. And you're going to get $22,000 in 2 years, which is equivalent to getting $1,585.88 today. So the whole package is comparable to paying $23,564.29. So again, you just take it one step at a time, and a problem like this is very straightforward.